Hello students, in this video we are going to learn about ASIC, Application Specific Integrated Circuit. In our previous video we saw about two design methods, namely semi-custom design and full custom based design. Now we shall see what this ASIC means. Okay, Application Specific Integrated Circuit. The name itself says it is an integrated circuit that is going to serve a particular application. So an applications oriented integrated circuit. So my integrated circuit will be used for only one particular application, and that is nothing but, in short, I can call it as ASIC. The application-specific integrated circuits are highly specialized devices because it is not like other devices. These ASICs are non-standard integrated circuits constructed for one specific purpose application only. That is what it is named as application-specific integrated circuit. It is constructed only for one specific purpose and they are not standard ICs. Because based on the application, your ICs do change. So we cannot say it is a standard IC. Application-specific integrated circuit are changing the way the electronic devices systems are designed, manufactured, and marketed. Previously, the systems were particular IC would have been manufactured or designed and that was marketed. But now we need the particular IC that is serving a particular application. So this ASIC is changing the way the electronic devices has been. So I will give an example for ASIC. So ASIC means application specific integrated circuit. It is going to serve a particular application. Means for satellites. Each satellite will be aiming a particular application. So I can include the chips for satellite. These chips will be ASIC chip. And also to run a cell phone. If I want to run a particular cell phone, I will be having a chip, and that chip and some other mobile will not be having the same chip. So that particular mobile needs to serve some application, and thereby they will be having a particular IC or chip. It is nothing but ASIC. So the chips which is designed to run a cell phone or satellite or a Bitcoin miner or for a voice recorder, and these are the examples of ASIC chip. Some ICs are not ASIC. It includes memory chips like ROM, RAM, ICs at low scale integration, SSI, MSI, medium scale level. Everything comes under the non-ASIC because this is a memory chip. The memory chip can be used for various applications. So it is a common that can be used for various applications. Maybe I may say that I want to store something. So a memory will be used that will be serving some purpose. And again, I can serve or use a memory for some other applications also. So these memory chips I cannot call that as an ASIC chip. Whereas some ASIC chips, as I said, that for cell phone, satellite, or for voice recording, everything will be coming under the ASIC chip. Using an ASIC chip, what is a major advantage? The design can be made into one circuit. Okay, whatever the design is there, everything can be made into an IC. That is application. Whatever application I need, that particular application, what are the necessities of the circuits, everything will be on that particular chip. And because of that, additional circuitries can be reduced. Meaning, I'm going to embed whatever I need onto one chip. So one particular chip will perform the function of all the necessary application. So I don't want any additional circuitries to be implemented or to be added. So modern ASIC chips are generally having 32-bit processor. See, one IC is going to have 32-bit processor, memory block, and some large building block. So that will be serving one particular application. Such a modern ASIC chip is nothing but SoC. These days, SoC is being trending. SoC is nothing but it is a system on a chip. So on one particular chip, you are going to have the entire system, and that will be serving a particular application. And the ASIC designs will be carried out only for those. See, we are going to have a huge system on one particular IC, but do we need to do for maybe I need that particular I need that particular application for only few days. Should I do all these work and should I make a system on a chip that will be serving a particular application just for few hundreds of ICs? No, I don't want. So this ASIC designs will be carried out only for those products which have long production run. Also, the cost of an ASIC chip is high. It is recommended only for high volume products because I'm going to have an entire system on my chip, or it is going to specifically use for one application. And if suppose the application's need is huge, then I can go for ASIC chips, and the cost of the ASIC chip is so high. And that modern today, we are using the ASIC designers. What they are doing is they are writing a language, or there is a language so called as hardware description language. Means I'm going to describe my entire hardware using one language like Verilog or VHDL, very hardware description language, to describe the function and the design of my ASIC chip. So ASIC designer, they are going to describe your entire hardware, entire application using a language called as hardware description language. So there are basically three types of ASIC chips, that is full custom design, semi-custom design, and programmable ASIC. These are the different types of ASIC. So we have already seen about full custom design and the semi-custom design. And now the third, this programmable ASIC. See the broad classification of ASIC, which is application specific integrated circuit. For one particular application, I'm going to design my particular circuit or integrated circuit. So these ASIC circuits can be a full custom design, semi-custom, or programmable. And the semi-custom, we have already seen, it is divided into two, which is standard cell based and gate array based, where the gate array base was itself divided into channeled, channelless, and structured gate. Up to this we have seen in our previous video. So in the next video we will be learning about the programmable ASIC, which is nothing but we will be learning about the programmable logic devices. We will learn about PAL, PLA, and also about FPGA. So now these are the more classifications of your ASIC. And the important thing is, I'm saying that we are designing, but how I can design just like that? I need certain steps. So what is the design flow, or how my ASIC chip has been fabricated from the starting till the finish point? See, first there will be a design entry. I told that designers are using the language called as VHDL or Verilog for your design purpose. There will be a specification. Based on the specification, I'm going to code or write the language or a program that is nothing but your design entry. Once I have written that particular code, I will be synthesizing my logic. Means inside the computer there will be a language that is running, and that is going to create certain netlist. What is netlist? It is nothing but there will be a collection of logic gate and an interconnections will be there based on the program that we have written. Suppose if I was given with the next specification, I have coded the specification and I have simulated it, and I will be seeing the logs. I will be synthesizing my circuit, and if I synthesize that circuit, my program will be converted into a netlist. It will be having various nets or various gates, and there will be some connection. It will be creating the circuit for the program that I have written. And then I have to do the system partitioning. I will be partitioning my half of systems. And now I will again go for the pre-layout simulation. And next we will see what is that. I will just give the brief of all these things in this diagram so that the next slide will be a little bit easier for me to understand. So starting with the design entry, we moved on to the synthesis, and then we did the system partitioning. We checked for the pre-layout before the layout process has come into picture. In the backend itself, we just simulated it. If it is wrong, again you have to change the language and you have to do some changes in your program. Again you will be doing the synthesis and you will be going for the partitioning. If everything is through, we can go for floor planning. Means where your ICs, where your circuits has to be placed on the particular chip. Everything will be dealt with the floor planning. And then that is a back end. So now inside that, after floor planning, what is going to happen? The placement of the particular chips or placement of this particular circuits will be done in various blocks. That is where to place your component. Everything will be done or in your placement step. After the placement step is through, what we have to do, we have to give interconnections between the blocks, whatever we need. That is called as routing. So once routing has been completed, I can go for the circuit extraction. So it will be converting my circuit into the electrical circuit, and then I can go for the post layout symbolization. Before it has been sent to the marketing, before it has been fabricated, again I can go for a post layout. Once the layout has been done, I can go for post layout symbolization. So now see, I will just give the brief idea regarding this. Now we'll see what are the various steps that is involved here. So the design entry was the first step. The design will be entered. So the designer will be starting to design with a text description or a system specific language like HDL, C language, etc. But we usually use the HDL language. For writing, it can be either Verilog or VHDL. And then the logic synthesis generally helps to produce the netlist. That's what I told, that based on that language or the program that we have written, this synthesis step is going to produce the netlist that will be consisting the description and the interconnection of your logic cells. It's nothing but there will be gates. The structure will be there. For what program you have written, that particular structure will be there. And then here it partitioning of a large design into small ASIC design takes place. So in pre-layout symbolization, it allows checking whether the design functions correctly or not. Before it is being formed into a layout, I'm just simulating it whether the design functions are working correctly. In floor planning, we can plan the arrangement of the blocks present in the netlist. See, on your netlist, you can see what are the blocks that has been placed are available if I run that particular code. But in your floor planning, we can plan the arrangement of the blocks. And next step is placement. It allows the placement of the cells present in a block. So inside your block, there will be various cells where I want to place my cells. Inside your block will be dealt in the placement step. Once the placement and the floor planning and placement has been completed, this step is to provide the necessary interconnection. See, I have all the cells that are placed in various blocks. So we have to provide the necessary interconnections, and that is done in this step of routing. So next step is circuit extraction. Here the translation of the integrated circuit to the electrical circuit takes place. So post layout symbolization is nothing but it checks the final layout of the design. So this is a normal design flow of your ASIC, which is an application specific integrated circuit. It is specifically used for particular application, and it has been divided into 3 types. And we have covered full custom, semi-custom in our previous video. In the forthcoming video, we will be learning about the programmable ASIC that is divided into PLDs as well as your FPGA. And here there will be a design flow, and the flow is important. Only then we can design the particular circuit or the IC in an efficient and the correct manner. So this is all about your ASIC, and I hope you understood the video. In the next video, we shall see about the programmable logic devices.